Hi, this is Justin Pineda, and for this session, we're going to discuss Module 6, Infrastructure Security. So first off, to understand more how to defend the network and the infrastructure, we have to understand some networking concepts. And we'll try to simplify it so we can proceed to the security aspect of it. So for the networking concepts, we'll follow the Cisco's network architecture terms such as fault tolerance, which talks about high availability, scalability, number two, which foresees the future expansion of the network. Number three would be quality of service, which talks about prioritization. And the last one would be security, which talks about access to resources. And the good thing about the Cisco's network architecture terms is that it is applicable regardless of the brand that you are using. So we can pattern fault tolerance, scalability, QoS, and security to uh, whatever architecture you have, whatever design, and incorporate different types of brands. Okay, so for this course, we'll be talking about security, specifically the access portion, because fault tolerance will also fall under information security, but this mainly focuses on availability. Okay. Okay, so you remember this. So these are the concepts that we discussed during the first lesson. So the formula for protection, okay, which uh, is composed of prevention, detection, and response. So here, later on when we discuss the tools, we'll determine which tools provide prevention and detection and response. Although we'll not dig into the specifics because this is just an overview of infrastructure security. And also, in infrastructure security, it also provides defense in depth. So if you would remember, to access the data, in the concept of defense in depth, it has to pass through multiple layers of security. And we have different controls for each layer. So now we start with the layers of the OSI model. So um, in the networking courses, you should know this by heart, right? And you're tasked to memorize it in some cases. Okay, so this is the um, OSI model. Okay. It has 7 layers compared to the TCP/IP, which has 4. So initially, TCP/IP was the first model to be made public. However, because of standardization and creation of various protocols from different organizations, both from the government and private, the OSI model emerged, which became the de facto standard for um, classifying protocols and communication between different layers. Okay. So we call the OSI model as the reference model um, because uh, it is not literally divided into 7. So this is logical, and the goal is that if different organizations will create their own protocols, okay, the OSI model can help to establish standards so that these protocols can communicate with one another. Okay, and um, another thing that you have to be able to define is the difference between a hub switch and a router. Aside from the physical appearance and the number of ports, we need to be able to differentiate this. And in networking and security, the easiest way to differentiate these devices is through collision domain and broadcast domain. We call CD and BD. Okay, so when we say collision domain, it refers to the capability of the devices to transmit data simultaneously. So collision. So if there is one collision domain, it means that only one device can send at a given time. And if multiple devices will send, then there will be so no data will be sent. So it will crash. So there will be a collision. And when we talk of broadcast domain, it refers to the capability, okay, from the word itself, broadcast, okay, to transmit data to all other devices in a network segment. So if I send a broadcast and we are we have five devices connected, okay, in the network segment. So if I send a broadcast, the four other devices will be able to receive my message. So when we talk of collision domain and broadcast domain and use it to define devices, so it will be like this. So when we say hub, it is a LAN device, okay, which has one big collision domain and one big broadcast domain. So that means no matter how many devices are connected, only one device can send data at a given time. Okay, send data, send message at a given time. And when we say one big broadcast domain, it means that all devices in that network segment will be able to receive the um, the message. Okay. So there. And when we talk of switch, it's a LAN device that has one collision domain per interface and one big broadcast domain. So what does this mean? It means that each device, okay, connected to the switch has one collision domain, meaning it can communicate, it can send message simultaneously. And when we say one big broadcast domain, it has um, it has one big broadcast domain. That means that when the device sends a broadcast, all other devices will be able to receive it. And for the router, it is a one device. So when we say one device, it talks about IP addresses. It talks about the network layer. So it is able to first it's able um, to send data to outside of the network. Okay. At the same time, it has one collision domain per interface and one broadcast domain per interface. So each of the segments will have their own separate broadcasts by default. And alternatively, we can define other devices using the earlier descriptions. So when we say repeater or network repeater, it's just a hub, but with less ports. When we say bridge, it is a switch with less ports. Okay. Usually, it just bridges the two networks. And a firewall is similar to a router. So they are both one devices with both um, one collision domain per interface and one broadcast domain per interface. Okay, so let's have an example. Determine the number of collision domains and broadcast domains. So for this example, so remember if it's connected to a switch and a router, it has one count um, for the collision domain per interface. So let's count. So we have 1, 2, 3, 4, 5, 6, 7. Bridge is switch 8, 9, and 10. So that means I have 10 collision domains. Right. How about for broadcast domain? So in the broadcast domains, only the router has one broadcast domain per interface. So let's count. So we have 1, 2, 3, 4, 5, 6, and 7. So I have 7 broadcast domains. Okay. Let's check if it's correct. 1, 2, 3, 4, 5, 6, 7. Okay. So that's for example 1. So we only have one example. Okay, let's now go to security devices. So now we know the network devices, the layers, and its corresponding protocols, how it works. We can now go to the security devices. So we'll just show some of the many um, security devices that you can implement in the infrastructure. So these are the common ones. So the first one is the firewall. So the firewall is a preventive tool because as defined, it enforces a security policy. What should be allowed? What should not be allowed? So if it's in the policy and it says allow, then you will be allowed to enter either ingress or egress, going in or out of the network. It's usually placed at the start of the LAN, okay, or the topmost of the network, topmost portion of the network. And it uses ACLs, okay, and enforces an implicit deny rule, which means that if it's not explicitly configured to be allowed or deny, by default it's denied. Okay, so that's the implicit deny rule. If there's no rule, deny. So here's an example of the firewall topology. If you would notice, the firewall again is in the outermost area um, of the network. So it's like the gate, okay, that checks for all the traffic that goes in and out of the network. So if you would see, there is, for example, we have going in port 443. Okay, what protocol is this? This is HTTPS, right? Okay, so it allows HTTPS. Okay, for 53, this is what? It is a traffic going out, and 53 is DNS. Okay. So it checks whether it's allowed to get in or out of the network. Now, there are three types of firewalls that we will discuss for this lesson. The first one is packet filtering, which checks the following information. Okay, we call it the header because it's the header file. Okay, header information of the data. So it checks for source and destination IP addresses, source and destination port address, and protocols. So these are the only things that it checks. So it's the most common type of firewall, but it does not provide um, very complicated rules for allowing traffic going in and out. Okay. So in the example, if somebody will access the school's web server, what port should I allow in the firewall? So if it's a web server, then we'll allow port 80, right? And we allow TCP um, port 80. Or if it's using secure web, it's port 443. But in this case, it did not specify, so it will allow port 80. Okay? So Now, let's have this type of rule in the firewall. So if there's a firewall rule that says permit TCP/80 any um, permit TCP 20 and 21, which services will be allowed by the firewall? So any usually in your creation of your policies, this means source network and destination network or IP. Um, so when we say any, it means any source and then any destination. Okay. So which services will be allowed by the firewall? So we have port 880. Port 80. We we mentioned this in the previous slide. This is web. Port 20 and 21. This is FTP. So this means that the firewall will allow web and FTP. Okay. So it will allow FTP, correct, and HTTP or web traffic, but it will deny any other traffic due to implicit deny rule. Because there is no other rule, therefore it will deny all other types of traffic. So, so applying this, okay, connecting to apc.edu.ph, okay, will the firewall allow this traffic? This uses port 80, so yes. Okay. Connect to telnet apc.edu.ph port 23. So it will not be allowed because there's no rule stating allow. Okay, connect to FTP apc.edu.ph. So this will be allowed. So allowed, denied, allowed. Also, you have to remember in the networking concepts the three-way handshake, which is the SYN, ACK, and ACK. That is in your networking concepts in OSI, particularly when we talk about TCP, okay, in layer 4, which is transport. Why? Because the second type of firewall will involve something. Um, the second type of firewall will be applying some of the concepts in the three-way handshake. So the firewall dilemma is now the limitation of the packet filtering firewall. What happens if user 1 communicates at apc.edu.ph? Okay, so there is a SYN packet, okay, and then APC server will reply SYN ACK, okay, but instead of replying back an ACK or acknowledgement, the user sends another SYN. Okay. Meaning to say, the user does not complete the three-way handshake, yet communicates in an allowed service. So what will happen? Similar to what we discussed about communicating with other devices. Let's say if I send a ping, ICMP echo request, the default response of the target would be to send a reply. And in this case, the three-way handshake did not complete, but the user sent another SYN packet. Therefore, the APC server or the target will reply back a SYN ACK because that's how the behavior would work, right? By default. So SYN ACK, ACK. But if there's no ACK, and if I send another SYN, okay, the target will reply SYN ACK. And the problem with this is that if the user sends, okay, and I have to emphasize this, although this is theoretical, but if the user sends 1 million SYN requests to the web server, okay, using a script, will the firewall, if you're using a packet filtering firewall, allow it? So the answer is yes, because it says in the rule TCP/80 permit, right? For permit TCP/80 any. So that means even if I send 1 million SYN requests, and that is obviously malicious or suspicious, but since when it passes through the packet filtering firewall, it sees that it uses port 80, then the firewall will allow it. And that's the problem. So it may exhaust all the resources of the APC server and it may go down. So that's why there's another firewall called the packet inspection firewall, which is also known as the stateful firewall. Now, for this type of firewall, it also checks um, another aspect aside from the header, because as mentioned in the header, it only checks the IP, the port, and the protocol. Okay. So source and destination IP, the port, and the protocol. In the packet inspection firewall, it also has what we call session state. It checks the session state of the connection and maintains what we call a a state table. So how does it work? So let's simulate. So the user once communicates again to APC server. So it sends a SYN, a SYN packet, and then it will be recorded here in what we call the state table. And then APC server will reply back as in ACK, and then it will also be recorded in the session table. Okay. And then next, user 1 will not complete the three-way handshake. Instead, it will send another SYN packet, and it will also be recorded here in the state table. And then the firewall will note that it did not complete the three-way handshake. Okay, so what will happen is that it will kill the connection. So meaning the 1 million packets that you will send that is only seen will be reset by the firewall, or depending on the policy, but it will be dropped. So that's the purpose of the packet inspection firewall. So it checks another layer and then maintains a state table. Now, the third type of firewall is the application firewall, okay, which also is known as the proxy firewall, so application or proxy. So here, it checks data up to the application level. So if you would remember your OSI, right, so it starts with physical, data link, network, transport, session, presentation, application. Okay. So for the proxy firewall, it checks all the layers, starting from the data link up to the application. Okay. And it checks for content also. Not only the header, not only the session, but up to the content of the information itself. So for example, this is the um, example of the enforcement of policy. Example, I open the browser and I go to apc.edu.ph. So it will check one by one the pages that load. Okay, like for example, oops, this content is allowed because the category is schools. Okay. But the other pages that I mix in the website, like some announcements from Facebook, will be blocked because the category is social networking. Also, if it's coming from Inquirer, I will block because it's news and it's not allowed in our policy. So these are some examples of the application firewall. Applications of the application firewall. Okay, so now we go to which firewall should be used in your network. Okay, so the management question is, why not just buy an application firewall since it has all other features? That's the common question. Why not buy an all-in-one? Okay. Now, the answer would be it will depend on the need, right? Because if the application firewall will be deployed, since it checks all layers, it will be slower than the normal firewall. That's why at the at the at the usual implementation, it's the packet filtering firewall that is placed at the topmost part of the network because it has to be fast. It has to check the traffic faster. And you can implement the application firewall inside the network, a specific network segment that you would like to check, usually the internal network. And you put a packet inspection or stateful firewall in the demilitarized zone, which we will discuss later, because these are the this is the zone where most of the denial of service attacks happen. Okay. Now, let's go to the second device. So after the firewall, usually you have what we call an IDS or intrusion detection system. So obviously there are malicious traffic that passes through the firewall, even if you have an application firewall. Okay, if there's a script injected and passes through the network, the firewall might allow that type of traffic. So you have to put what we call a detective control, such as the IDS. So we have a detective control. This is usually placed after the firewall, and it checks traffic based on signatures or patterns. Okay, it also checks for anomalous traffic or behavioral traffic. One of the open source types is Snort. And this is free to download and there are a lot of mashups with other tools. So if you deploy a free firewall like pfSense, you can use Snort as its IDS engine within pfSense. So that's a good combination for those who will be setting up on their own. So the usual setup, okay, can be like this. Okay, so this is the first setup. This is the second setup. So the first one is um, where where Snort is connected to the firewall. Okay, as a regular interface. So if this in this implementation, if Snort dies, okay, the traffic can still pass through. Whereas in the second implementation or second topology, when Snort dies, nobody nobody can access in or can go out of the network because everybody the traffic will will not be allowed because the device is dead. Okay, so we call it inline traffic. Okay, so you have to check which one is more suitable for your organization in case the IDS fails. Now let's go to some of the engines of the IDS. So the first one is the signature base engine, so which checks for known malicious traffic that won't be checked by the firewall. So in this case, it has a signature base, okay, where it matches patterns, okay, and if it matches, then it will be tagged as a potential suspicious or malicious traffic. So in this case, okay, so this is an example of a cross-site scripting attack, right? Okay. So if I click sign in, okay, the firewall will by default allow this type of traffic because it passes through an allowed port number. Okay. However, if you have a if you have an IDS, it will have list of rules that if it matches, like for example, in the IDS, there's a rule that if I see um, less than or greater than symbols and quotation marks and a slash, I will consider this as a potential cross-site scripting attack. I will flag it and then I will report it to the administrator. So because we're not expecting these types of characters as a username. So that's an example. So it will be tagged and it will be notified through email or SMS depending on the configuration. Or you can set it to auto block in the firewall. So if I see something like this, okay, I will send the source IP to the firewall and block it. The second engine would be the anomaly-based engine. So it checks for abnormal traffic and unusual behavior and patterns. And the usual example is creating an anomaly-based rule wherein, for example, if the source IP connects to a login page multiple times, like let's say, let's put a threshold, let's say 10 times in 5 seconds, I will flag it as malicious because potentially it might be a password attack. Okay, password attack can be a brute force attack or dictionary attack, I don't know. But we're sure that this is not done by humans. There might be a script, an automated script that does that. So I have to tag it and report it as an anomaly. So that's the example application of the anomaly-based engine of the IDS. Now, let's go to this. Next is, what do you call the attacks that are not detected by antivirus? And companies, how can antivirus companies learn about it? So we call it, so the first one, what do you call the attacks that are not detected by an antivirus? Usually these are called false negatives, meaning there's no signature for it yet. That's why even if you use an antivirus or anti-malware, it will not yield you, it will not give you positive results. That's why it's called false positives. And these attacks are also called the 0-day or O-day attacks, meaning to say nobody knows it yet. Okay. It will still be discovered in the process. So how can EV companies learn about it? So there are many ways. It can either be through their researchers discovering the 0-day. It can be through um, it can also be through reports by customers about um, suspicious behavior of their computers. And another way is through what we call honeypots. So honeypots are intentionally vulnerable network for hackers to mislead them into thinking they have gained unauthorized access into the company networks. It's an actual vulnerable network, intentionally vulnerable network. So attackers can put or attackers can attack this network, but they won't be able to get a lot of information or useful information because it's um it's just a double or a spoof network. And the goal is first in most organizations it's to protect the actual network, and for some companies they use it to learn about the attacks of the methods or the tools used by the attackers. And in some cases, they learn the um, new attacks, the zero-day attacks, and they inform anti-malware companies, or sometimes anti-malware companies have this in place. Okay, so here's an example of honeypots. Okay, so there's a honeypot demilitarized zone, IDS systems. Okay, you can have an anonymous access DMZ, an internal network, an authenticated access perimeter network. So it might be depending on what happens in between these firewalls. If specific conditions are met, you will be transferred to a honeypot or to the correct network, depending on the behavior, okay, or depending on the conditions met. Okay. So now let's go to security infrastructure best practices. Okay, so now we learned some network concepts, security concepts. What are the security infrastructure best practices? So first, in the usual corporate network topology, so this is the implementation. So you have the internet, you have the internal network here, and we have you have a server network which is also called the demilitarized zone. So there's the untrusted zone, which is the internet. We have the DMZ, okay, which is the consists of the servers, and the trusted zone, okay, which is your corporate network. So in the trusted zone you can put a lot of security controls such as antivirus. You can strengthen the security policies in the trusted zone. Okay. The reason why you have a separate DMZ is due to the fact that servers are usually accessed both by the people in the trusted zone and people from the untrusted zone. And the goal is for you to be able to contain if there is an attack or an outbreak or whatever attack, okay, that it will be contained in this zone only, in the DMZ, and it will not affect the trusted zone. Okay. So this is the usual um, corporate topology implemented. Okay. So again, the purpose of the DMZ is to contain traffic to servers in one network segment only. Okay. Another implementation would be the use of intranet and the extranet. So when we say intranet, is the network that can only be accessed by the users in the trusted zone. So when you're at home, you won't be able to access it, okay, by default. When we talk about extranet, these are connected intranets that communicate with one another. The implementation is very good because it will only be limited to the people in the network. Okay, so no external attacks by default in an ideal setup. Okay. However, in the perspective of the business, this is not good because people outside cannot access the resource. Like if you're working from home, that's why, okay, the solution would be, so if how will I be able to connect to the intranet remotely? So through the use of what we call the VPN. Okay, so VPNs secure data sent by insecure networks such as the internet The goal is to provide privacy provided by a circuit such as T1 virtually. Okay. So it's like having a secure tunnel from point A to um, to the corporate network. So you establish connection, and there are a lot of authentication done on both ends before you're able to access the corporate network. And other ways to secure the network would be in the switch, you can enable port-based network access control. Okay, you can ensure that only devices registered in the organization can have access to the ports. Okay, for the routers, okay, you can do whitelisting and blacklisting of MAC addresses as one type. There are many other types of configurations that you can do, like limiting the number of IP addresses that you can use in DHCP, etc. Third, for the hubs, do not use hubs anymore. Okay, this is not advisable because even in the cost, comparing it with the switch, they they have a very small price difference nowadays. And for computers and servers, so it's advisable to install a host IDS or a WAF, aside from the common anti-malware applications. Okay. So, yeah, so we to summarize, also we discussed number one, some important networking concepts, and we applied in number two, different security tools and concepts also, okay, to ensure that your network is secure in the infrastructure. And third, we also discussed um, the security best practices that you can implement to make your infrastructure more secure. So thank you very much for listening. If you have any questions, you can email me or you can post your comments below. Thank you very much.